Dear learners, so today we shall be looking at the preparatory examination 2024 geography paper 1, which were 3 hours. Those are the instructions which we are all familiar. So this paper consists of question A, question 1, climate and weather, 60 marks. Question 2, geomorphology, 60 marks. And section B, which is question 3, geographical skills and techniques. Number 2, they say answer all 3 questions. Then number 3, all diagrams are included in the question paper, meaning the addendum or the annexures are within the question papers. So number 4, leave a line open between the subsections of questions answered. Start each question at the top of a new page. Number answers correctly according to the numbering system used in this question paper. Do not write in the margins of the answer book. Draw a fully labeled diagrams when instructed to do so. Answer in full sentences except when you have to state, name, identify, or list. Units of measurements must be indicated in your final answer. For example, 1020 HPA or hectopascals, 14 degrees Celsius, and 45 meters. So they do indicate for us the various units of measurements, like for pressure. As you can see here, pressure indicator is supposed to be hectopascals. Then temperature, Celsius, and the units for measuring height, which would be meters, etc., something like that. So you may use in a programmable calculator, you may use a magnifying glass, especially when it comes to map work, because at times some of the features could be too tiny to identify them with our eyes. Write neatly and legibly. Specific instructions and information for section B, where they say a topographical map and the orthophoto map. The area demarcated in red or black on the topographical map represents the area covered by the orthophoto map. The marks will be allocated for steps in calculations. That's why we always emphasize learners to indicate all the steps so that they don't lose out on marks. Number 17, you must hand in the maps after this session. So today we shall be going through this paper to see what you are supposed, what you were supposed to write as your answers. All right. So section A, which is climate, weather, and geomorphology. We shall start with question 1, which is climate and weather. Apologies because I see the question paper that was uploaded. It has some marks, but we shall see if these are the right answers that have been underlined. So they say various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question number. So always in our answer book, we should indicate the question number, and the letter, which is the alphabet, according to what is given to us. So question 1.1.1 says, urban heat island can be described as option A, urban areas being colder than rural areas. So this one is out because we know that always in most cases urban areas are warmer than the rural areas. Then option B, urban areas receiving more insolation than rural areas. Still, this does not define a heat island. Now option C, it says urban areas being warmer than the rural areas. So I think option C is correct as it was underlined here. So we shall go to option C because it clearly defines an urban heat island, where we usually say urban areas being warmer than the rural areas. Question 1.1.2. Urban heat islands can develop because of urban heat islands can develop because of, if you look at option A, the reduced number of vehicles, not really, reduced industrial activity, because the first options are also all indicating how to reduce on heat islands. In number C, large open water sources. So the three options could somehow indicate how a heat island could be reduced. So, which means option number D will be our answer, where we say larger artificial surfaces, they absorb and retain more heat, which contributes to the heat island. So we shall go with option D. 113. The following photograph shows dash dash due to a large glass surface in an urban area. So for our case, the following photograph shows dash dash due to a large glass surface. As you can see, this is a large glass surface here. The whole of this building, it has glass surface. So when we focus at this point, you can see heat is being reflected back. It means the glass was able to absorb, then afterwards it was reflecting the heat, or it was bouncing the heat, which we will refer to as albedo. So option number A will be our correct answer, as the following photograph shows albedo due to a large glass surface in an urban area. So albedo, this is when surfaces reflect or bounce back the heat that they received from the sun. 114. A pollution dome located over an urban area would be dash dash and dash dash dash. So for this case, 114, a pollution dome, because all of us, we could say a higher during the day, which is correct, because if you look at if you try to illustrate it here, during the day, this could be the buildings, and you can see the dome is way above the buildings. If you look, then at night, the dome moves closer to the buildings. So this would be a night, and this would be day. Now, if you look at our options, a pollution dome located over an urban area would be higher during the day, which is correct, and this is out because it cannot be lower. It isn't lower during the day, lower during the night. Good. So it means that's the last option. Higher, no. So these two options are out. So meaning you're going to consider a pollution dome being higher during the, as you can see, these are the buildings. Look at the dome. It is way far from the buildings. Then at night it will be lower. That's why we consider 1 and 3, because like we showed here, during day it's way higher. During the night, you can see it is closer to the buildings, that's why we take option A as our correct answer. The next question says, refer to the sketches A and B below showing wind direction in valleys to answer questions 1.1.5 to 1.1.7. Dear learners, I think we all know, we look at the position of the arrows, the direction of the arrows. So you can start in diagram A, the arrows are pointing upwards, and in diagram B, the arrows are pointing downwards. So we all know the movement, since we're dealing with the wind. So it shows that the wind in diagram A is moving upwards, and diagram B the wind is moving downwards. Meaning, as the question says, wind direction in a valley. So you can see the side they are steeper. They're steeper. Then we have a valley at that point. This one with this other one steep. Then we have a valley in there. Therefore, so the question says 115. The wind illustrated in sketch A. This is our sketch A here, where the arrows are pointing upwards, or showing the winds moving upwards to the valley tops. That would be the anabatic winds, because we know anabatic winds are winds that move upslope because they are lighter in weight. 116. The wind illustrated in diagram B is most prevalent. As you can see that this is the winds are moving downwards because the air is cold and dense, which indicates that this does occur during the night time. Because at night time, we know that the valley slopes loses the heat through terrestrial radiation, which results into the air becoming cold. And when air becomes cold, it will be dense in weight. Therefore, it will be forced to subside or to move downwards during the night time. That's why option B will be our correct answer. 117. It says frost pockets will likely form in diagram B because of, I think all of us know what is a frost pocket. We know that's the point where just a second. Yeah, this point here, a point where cold air accumulates or settles at the valley bottom. So where cold air settles at the valley bottom, it will form the frost, or we shall refer to that area as a frost pocket, because as cold air moves downwards to this point, so it will settle at this area. Where it settles, we'll refer to that region as the frost pocket. However, 116 says frost pockets will likely to form in diagram B because of accumulation of cold air. Like I just mentioned, they form as a result of cold air subsiding to the valley bottom, where it will then settle. That is question 1.1 out of 7 marks. We proceed to question 1.2, which says, read the statements below and choose the appropriate words in brackets that will make the statement true. Write down only the question numbers. For example, 1.1, 1.2.1 to 1.2.8, and the answer in the answer book, as they've indicated with that example. All right. Question 1.2.1, it says, the global wind belt responsible for the general movement of mid-latitude cyclone is dash. So they give us two options, where they're saying polar easterlies and tropical easterlies. So we have to choose one. However, I see something wrong with this question, because whenever we talk about the general movement of the mid-latitude cyclones, we know that they move from west going to the east, right? And the winds responsible to enable the mid-latitude cyclones to move from west to east, that would be the westerly winds, because we call them westerly winds as a result that winds are named from where they originate. So westerlies, they originate from the west, therefore they move towards the east. It is the same reason why we shall say that the mid-latitude cyclones will be driven by the westerly winds. Therefore, I think there was something wrong with the question. Either they were supposed to indicate, maybe if we are supposed to take out this one, the tropical easterlies, then maybe we indicate it with the westerlies to make the question more correct. Because we know the mid-latitude cyclone, it develops when these two winds meet at the polar front. The polar easterlies, which moves to the west, then the westerlies, which moves to the east. Therefore, the correct answer is supposed to be the westerlies, are the winds that are responsible for the movement of the mid-latitude cyclones to the east. Right. 1.2.2, it says, the diagram below shows a mid-latitude cyclone in the initial stage stroke development stage. As you can see, already you can see the feature of a cold front, the feature of the warm front, and there is a depression which is starting to develop here. So meaning that this cyclone has moved away from the initial stage where we showed the westerlies and the polar easterlies. So then it moves to the development stage. Then from development stage, of course, it will be the mature stage. Therefore, we say this will be the development stage. Question 1.2.3. The diagram below depicts a succession stroke a family of cyclone. As we all know, where we see, because when they say family, that means it is more than one thing or more than one cyclone. And you can see this is a cold front here. This is a warm front, which is already one. So they're showing us the low pressure cell, which is a one cyclone. Then another, again, we have a cold front here and a warm front here, which also indicates another low pressure system, meaning so we said, sorry for the interruptions, there was some connectivity problems. However, so we said that our answer will be family of cyclones. Question 1.2.4, it says the front at B below, is it warm or cold front? This is front B here. As we all know that the symbol for the cold front forms a triangular shape. Then for the warm front forms a semi-circular shape. So this will be for the cold front, and this will be for the warm front. So meaning that symbol B will be it indicates a warm front. 1 to the other question, is it 1, 2, it's 1, 2, 4. Okay, they say, refer the diagrams below to answer questions 1.2.5 to 1.2.8. Question number 1, 1 to 5. Nimbostratus stroke cumulonimbus clouds are most likely to develop at A. So this is A. As we know, A, this is a cold front, and within the cold front, whenever a cold front approaches an area, there will be intense condensation, which will result into accumulation of these dense clouds. And you can see they are tall and huge, and such type of clouds are referred to as the cumulonimbus clouds. That will be the cumulonimbus clouds at A. Number 1.2.6. Gentle rain can be expected at B because warm stroke cold air rises steadily above the cooler air masses. If you look at this is our B here, so we shall experience gentle rain as a result of the warm air rising steadily or gently above the cooler air. In 127, the occluded front depicted in diagram C is warm stroke cold occlusion. So the answer is going to be the cold occlusion. As we all know, when you check here, behind the cold front is very cold, and even the other side ahead of the warm front is also cool. So which is an indication that this is a cold occlusion front, and as well the cold front in most cases it touches or reaches the surface, and the warm front is just in the middle, that it has been intercepted at this point, so which indicates that this is a cold front occlusion. 128, the occlusion in diagram C is the result of the cold air that moves faster than the warm air. As we all know that cold air is more denser, that's why it will move faster and to catch up with the warm front. So it will be our answer will be faster. So this question 1.2 was out of 8 marks. We proceed to the next question, 1.3, which says, refer to the sketch below showing line thunderstorms. Showing line thunderstorms. Okay. Refer to sketch below showing line thunderstorms. As you can see, firstly, we look at there is a high pressure cell here, which is the South Atlantic. We have the cold Benguela currents. We have the moisture front. Then also we have the South Indian high pressure cell. Well, this side we have the warm Mozambique current. Question 1.3.1 says, what is a moisture front? Sorry, what is a moisture front? I think we can use our blank page here to define a moisture front. 3.1. Here we can say the boundary stroke, a zone where the northeast warm winds meet with southwest cold winds. Or you could also define it as the zone stroke boundary between two different air masses with different moisture content. Right. So a boundary where the northeast warm winds meet with the southwest cold winds, or a zone between two different air masses. The moment you mention two different air masses, it means you are referring to the warm winds and the cold winds, right? So going back to our question paper, you can see that this is the moisture front. This is the boundary that we are referring to, or a zone. So this zone, we see these, we shall refer them as the southwest cold winds. The southwest cold winds. Southwest cold winds. All of us know why these winds are cold, because they cross over, or they are being influenced by the cold Benguela current. So then we have the northeast warm wind. So this will be our northeast warm winds. We know why these winds are warm. Also, they are being influenced by the warm Mozambique current. So this side is warmer and this side is colder. Therefore, the winds blowing over this area, they are going to become, they will be cold winds with less moisture content. Then this other side, there will be warm winds with more moisture content. So we use the concept northeast because if you look at our compass, we know that winds are named from where they originate, where we have those winds. That's why we call them the northeast. Then these winds, call them the southwest, because they originate from the southwest, originate from the northeast. If you check here, so that's how we could define a moisture front. Right. Question 1.3.2, it says, state one piece of evidence from the diagram indicating that line thunderstorms are occurring. How can we tell that there are line thunderstorms on this diagram? All right, that is question 1.3.2. Let's use our black page here. 1.3.2. Let's check the question once again. It says, state one piece of evidence from the sketch indicating that line thunderstorms are occurring. All right. So we could say, So evidence to indicate there's a seam of the moisture front here. Can you see the seam of the moisture front? There's a moisture front. Oh, there's okay. So it could indicate there is a symbol for the line thunderstorm, because no line thunderstorms develop over the moisture front. So there's a symbol for the line thunderstorms, right? Not this one here. Symbol of line thunderstorm. Because no line thunderstorms, they occur along the moisture front. Or even if you just say they are thunderstorms, I think that could also, as you can see, the symbol for the line thunderstorms, right? Yes. Then we got question 1.3.3. It says, use information from the sketch and explain why there will be more clouds located in the eastern part, instead of the western part of South Africa. Why? Because the question says why there will be more clouds located in the eastern part instead of the western part of South Africa. So as we all know, this will be the eastern part of South Africa, this side. This will be the western part. So meaning over this other side, which is the eastern part, there will be more clouds, and this side there will be less or no clouds at all. But we need to explain why. Okay, so let's use our blank page for 133. So we can call this 133. So we could say that the cold air from the South Atlantic versus warm air from South Indian high to rise or to ascend. Then we say the warm air will condense forming dense clouds on the eastern side, right? Because the question is asking, why would there be more clouds on the eastern part than the western side? If you look at the question once again, so we know that when the two winds meet at the moisture boundary or the moisture front, the warm air will be forced to rise, then the cold air is going to subside because it is more denser. Then the rising warm air is going to result into formation of these heavy cumulonimbus clouds, which will result into heavy rainfalls on the eastern side of South Africa. So we say this side will be heavy cumulonimbus clouds that result into more rainfall on the eastern part as a result of the cold dense air, which did undercut the warm air, forcing it to rise, forming those cumulonimbus clouds. So we could as well say, or define it in, explain it in this one, we say the cold air from the South Atlantic high had less moisture compared to the warm air from South Indian high. Which had more moisture. Then you go on to say the warm air was undercut by cold air, forcing it to rise, condense, forming the heavy clouds. Yeah, so that's how we could answer question 1.3.3. All right, then we proceed to the other question, which is 1.3.4. It says, in a paragraph, explain how summer position of the high pressure cells in bracket and cyclones promotes the development of line thunderstorms. The position of the anticyclones, how they promote the development of line thunderstorms. Right. All of us know that line thunderstorms, they develop in summer, where in summer the Kalahari is weak. If it is weak, then there will be development of a low pressure cell, which will result into a pressure gradient, meaning that there will be warm air from the South Indian high coming in, and also cool air from the South Atlantic. So you can see there is a pressure gradient between the Atlantic high and this low pressure cell, and as well there is a pressure gradient between the Indian high and this low pressure cell, which we call the heat low or the thermal low. However, we know the pressure gradient could refer to the difference in pressure. As you can see, this side we have a high pressure, this side we have a low pressure cell over the interior. So meaning that in summer the Kalahari weakens, resulting into the development of a low pressure cell. Now, the moment there is this low pressure cell developing over the interior, now this will allow the movement of A, because we know that A moves from a high pressure going to the low pressure, from high to the low pressure. So this was possible due to the weakening of the Kalahari high pressure cell. Okay, so let's see how we can explain this. We could say that in summer, okay, I think we need to use our blank page to explain it nicely. That is question 1.3.4, and we say that in summer, the Kalahari high pressure cell weakens due to intense heating of the land, right? So this results into the development of a low pressure over the land, creating a pressure gradient, right? Then we say, after that happening, it will allow warm, moist air from the Indian high, and the cold air from the Atlantic high, from the Atlantic high, from the Atlantic high, converge or meet at the interior. Right? Okay. The cold air from the Atlantic high will undercut the warm air from Indian high, forcing it to rise. So in brief, that is how the high pressure cells promote the development of the line thunderstorms. If I can take you back briefly to what I was illustrating here, like I mentioned that in summer, the Kalahari weakens, which results into the development of the low pressure system. Now, these low pressure systems, it's like it allows now the movement of air from this high pressure cell, because already there is a pressure gradient between A and B. So A will be moving from A to B, where A is a high pressure cell and B is a low pressure cell, and as well A will be moving from C to B, because C and B there's a pressure gradient. So as they meet at this zone, that's where we shall have now a moisture front developing, resulting into the formation of the line thunderstorms as well. Okay, so let us proceed to our next question, which is 1.4, which says refer to the infographic on tropical cyclone Freddy. The infograph. So it means that we have various information that we need to interpret and analyze. Okay. So there is various information that we need to understand here. Talk about the movement of tropical cyclone Freddy. As you can see, this is Madagascar here. Madagascar, meaning this is part of Southern Africa here. Then indicating how it was moving, because we know they move from the east going to the west, because you can look at the date 11, 15, 19, so on. This one can also show us the various latitudes. This is as you can see, this is S, meaning that we're in the southern hemisphere, because in the south degrees increase to the increase going downwards in the southern hemisphere. They indicated here from the 5th of February to the 4th of March. Meaning that's how far it formed, then before it dissipated. Then down we have a satellite image of Freddy, and as well as this other information here. So if you can check the information, it says tropical cyclone Freddy was an exceptionally long-lived That means it lasted for long. Powerful and deadly storm that traversed the southern Indian Ocean for more than 5 weeks in February and March of 2023. Freddy made its first landfall near Mananjari in Madagascar. The storm rapidly weakened over land but re-strengthened in Mozambique Channel. So, meaning that after passing Madagascar, it gained its strength once again. So the cyclone, the other paragraph, the cyclone struck southeastern Madagascar, damaging many homes. The impact in Mozambique was more severe than in Madagascar and included heavy rainfall in the southern half of the country. Hardest hit was Malawi, where incessant rains caused catastrophic flash floods, with Blantyre suffering the brunt of it. The nation's power grid was crippled, with its hydroelectric dam rendered inoperable. Food security was of particular concern, with millions of people left at risk. Okay, let's see some of the questions. 1.4.1 says, according to the infographic, what was the lifespan of Tropical Cyclone Freddy? Because now they're telling us to look at the information, right? To find out how long did Freddy last. And I think you remember our first paragraph where it says Tropical Cyclone Freddy was exceptionally long-lived, powerful, and deadly storm that traversed the southern ocean for more than 5 weeks, right? So in February and March of 2023, so it was there for more than 5 weeks, right? More than 5 weeks. 1.4.2, quote an example of infrastructure damage caused by Tropical Cyclone Freddy as mentioned in the article. Quote an example. So this was a 1 mark question, as you can see, 1 by 1. So give 1 point, again you get 1 mark. Then here we need to quote. Quoting means we write it the way it is in the article. We don't have to change any word or any letter, right? So let's check again. An infrastructure damage caused by Freddy. Let's check. The first paragraph, there was no damage. Second paragraph, Freddy made the first landfall. The storm rapidly weakened. The second struck southern eastern Madagascar, damaging homes. As you can see, this is one of the other infrastructure damage, damaging homes. Then the impact on Mozambique. Nation's power grid. Nation's power grid was crippled. All these are infrastructures, houses, roads, electricity. So they say hydroelectric dam rendered inoperable. So here the infrastructures, the homes, the power grid, and the hydroelectric dam, right? So that's what we're going to include on our question here. We could say, remember, we need to put quotes. So power grid was, as we saw here, let's check again. Power grid was crippled. And we write, make sure you indicate the quotes to avoid being penalized. Power grid was crippled. In close quotes. So since they only wanted the 1 example, however, so there were others like damaging many homes, and also hydroelectric dam rendered inoperable. So But since they wanted only one, we can proceed to the next question, 1.4.3, which says, describe the rotation of winds as depicted in the satellite image. This is our satellite image here. As you can see, the clouds, how they are rotating. So look at the pattern. See here. Can draw arrows to assist you to get the exact direction. So you see the clouds here. So as you can see, if you use arrows, this is a clockwise rotation. So the answer would be clockwise. Clockwise rotation. Then number 4, 1.4.4. Suggest two possible reasons why Tropical Cyclone Freddy intensified from a Category 3 to a Category 5 cyclone between 11 February 2023 and 19 February. So to intensify, it's like it increased its strength, power, it became more dangerous. But what could have caused that? Right? So 1.4.4, I think shall use our blank page here. 1.4.4. Let's check the question once again. It says, suggest possible reasons why Cyclone Freddy intensified from a Category 3 to a Category 5. Because remember, cyclones are measured on a scale depending on their strength. So if you compare Category 3 and Category 5, it means that Category 5 was more dangerous as compared to Category 3. But what caused that for it to move from a Category 3 to a Category 5? So I could say, so I only want two reasons. I could say high rate of condensation, which increased latent heat, because we know latent heat is among the conditions that energize the cyclone. So I could say less friction as it had not yet landed on land. So meaning it was still over the water, which also, because we know cyclones over the water, they are energized more due to more latent heat, high evaporation and condensation. So this makes the cyclone to be energized more. I could also say the high temperatures over the ocean due to the warm currents intensified the cyclone. Remember, cyclones, they love those warm conditions. So over that Mozambique channel, we can see that there is we know that there are always those warm currents, of which favors more of the development of the cyclone, meaning there will be more evaporation, there will be high condensation, latent heat, among other factors. So that's how we could possibly answer these questions in regards to what could have made the cyclone to gain its strength. Right. Look at question 1.4.5, which says, what could have caused the rapid weakening of Cyclone Freddy when it made landfall near Mananjari? So what could have caused the rapid weakening of Cyclone Freddy? Right? This is 145. It's more like we're gonna give the opposite of question 144. Right? Could say friction with the land at Mananjari. Weakened the cyclone. Right? So we know whenever cyclone approaches the land, there will be that frictional drag, which eventually weakens the cyclone. That's what we could say. There will be less moisture, over the land, resulting into less evaporation and condensation. Right? And as well, we could say there will be less latent heat, generation over Mananjari, which weakened Freddy. Among other factors. So basically, about friction with the land, less moisture, which means there will be less evaporation, less condensation, less latent heat, because over the land there will be evaporation, but that will be less, which now contributes to the cyclone weakening. Right? Then we proceed to question 1.4.6, which says, suggest 3 strategies that the local authorities in Mozambique could have implemented to prepare for the destruction caused by Cyclone Freddy. Remember, the question is saying the strategies or the measures who the authorities, local authorities or municipalities for this case, what could they have done to prepare for the destruction caused by tropical cyclone Freddy? That is 146. Okay, we could say the local authorities could evacuate people from low-lying areas. They could prepare evacuation centers to accommodate people. They also say ensure that people Let people stock enough medicines and food. Also, what else could we talk about? What could the local authorities do as well? Say put warning systems to alert people of the cyclone. We could also say thing also educate people about the dangers among others. So what this could be done by the local authorities, because remember the question is not asking what could people do, it is more of what could the municipalities or local authorities do to ensure that they promote right. So that is our question. So we proceed to the next question, which is question 1.5. It says, refer to the sketches A and B below showing the inversion layer. As you can see, sketch A, where they show the Kalahari, then they can see the substance here, the inversion layer. Look at the inversion layer position in sketch A. So this now we always must understand this concept of the positioning of the inversion layer. You can see in sketch A, the inversion layer has shifted a bit below, because this is the escarpment here, or the plateau. But the inversion layer has shifted below the escarpment. Then in sketch B, the inversion layer has shifted above the escarpment. Look at the moist air in sketch B. It is able to reach the escarpment. In sketch A, it cannot, because it has been blocked by the inversion layer. All right. Then we got question 1.5.1, which says, define the term temperature inversion. Let's say temperature inversion. An inversion, whenever you see an inversion, whether value inversion, temperature inversion, it refers to where temperatures increases. Sorry, let me start with temperatures. Then you can write temperatures increases. Temperature increases with increase in height. That will be that will be temperature inversion. So it goes against the other rule, which says the higher you go, the cooler it becomes. So for this case, the higher you go, the warmer it becomes. So at that point of the inversion, temperatures are increasing with an increase in height. 1.5.2 says, which of the sketches A and A or B represents winter? So we know that in winter there is strong subsidence, which pushes the inversion layer below the escarpment. So this is typical of winter, meaning that diagram A represents winter conditions. 1.5.3 says, provide evidence from the sketch to support your answer to the question 1.5.2. What evidence can we give to prove that this is winter? Of course, we could say that the inversion layer is below the escarpment. Inversion layer is below the escarpment, right? That's one. Secondly, we could also say the warm moist air is blocked. Warm moist air is blocked. Like we said here, you can see that the warm moist air cannot reach the interior because it has been blocked by the inversion layer shifting downwards. And as well, I mentioned that the moment you see the inversion layer below the escarpment, it indicates winter. In summer, you can see the moist air is able to reach the escarpment in summer because the inversion layer has shifted above the escarpment. All right. Then we proceed to question 1.5.4, which says, explain the likely stable conditions experienced in the interior of South Africa in sketch A. The likely stable, explain, right? Explain the stable conditions that will be experienced in the interior of South Africa. That is 1.5.4. Okay, we could say there will be clear skies due to strong subsidence, or there will be no rainfall. There will be no rainfall due to no condensation. Or there's also the air is dry because it warms up as it subsides. As it subsides, there will be sunny condition. There will be sunny conditions due to clear skies and no condensation. So the question was asking, let's check again. Explain the stable conditions, right? What are those stable conditions? Like I mentioned here, there will be clear skies. What causes clear skies? This will be due to the subsiding air, because in winter we know the air is dense and cold, so it subsides. As it subsides, there will be no condensation, resulting into clear skies. Again, there will be no rainfall due to no condensation, as we know that the warmest air cannot reach the interior. Therefore, there will be no condensation to take place to form rainfall. Then the air is dry. Why dry? This will be as a result of it warming up as it subsides, and as well will be sunny conditions due to clear sky because of no condensation. So that would be question 1.5.4. We proceed to question 1.5.5, the last question, which says, a farmer in the Free State wants to plant crops that require large amounts of water. Explain why the climatological conditions depicted in sketch B would be suitable for this type of farming. All right, so let's check again. A farmer in Free State wants to plant crops that require large amounts of water. So the concept here is, so you can see our farmer wants to plant crops which require large amounts of water. Explain why the climatological conditions depicted in sketch B would suit this type of farming. Right. I think let's use our blank page for question 1.5.5. So, checking again on the sketch. So you can see in sketch B, this is typical of summer conditions. Why? Like I mentioned earlier, that in summer, the inversion layer is above the escarpment, allowing the moist air to reach the interior. All right, so we are going to explain it in that regard, where we're going to say that diagram B shows summer conditions. So the summer conditions where the inversion layer is above the escarpment, right? But then you proceed and you say this will allow moist air, and say warm moist air to reach the interior, forming clouds resulting into rainfall, right? Then we say the more condensation over the interior results into more rainfall. Remember, the concept was the farmer needed large amounts of water. So how will the conditions diagram be suit that? That's why we are linking everything to the inversion layer, the escarpment, condensation, so which then in the end results into more rainfall. Okay, so this brings us to the end of question 1, which is climatology, out of 60 marks. Quickly proceed to question 2, geomorphology, which says, refer to the diagram below. Complete the statements in column A with the options in column B. Write down only Y or Z next to the question numbers 2.1.1 to 2.1.7 in the answer book. All right. So 2.1.1 says the longitudinal profile in the diagram represents a river profile. So this will be the ungraded river profile, because as you know, ungraded, it has got a profile with many base levels of erosion, which is not smooth. As you can see here, there is a waterfall already here, and there's a sharp gradient here. There's a waterfall, which indicates that the profile is not smooth, right? So 2.1.2, the river course indicated by X on the longitudinal profile is the course. The profile indicated by X, as you can see X, this is the upstream, which is typical of the upper course. To be the upper course, because we know this will be the upper course, middle course, then somewhere you're gonna have the lower course here. Lower course. Then 2.1.3, erosion is the dominant. So the erosion is the dominant erosion process at X, because we know vertical erosion, where a river erodes going downwards. For example, if this is the slope, and if a river is eroding going downwards, means that in the end there will be now a sharp gradient of this nature, because there was vertical erosion. So at X, because we know that this is the upper course, and in the upper course, vertical erosion is more dominant as compared to the lateral erosion. 2.14, the sharp drop in gradient indicated at B on the diagram is known as sharp drop at B. So this is going to be a waterfall, because you can see waterfall is more longer than the rapids, though they could both be correct. However, we consider the waterfall because it has got a sharp drop, more of a cliff. 2.15, erosion may result in the removal of the temporary base level at B. At B could be which is a waterfall, so it's going to be the headward erosion, because no headward erosion, river erodes backwards, moving away all those temporary base levels of erosion. Yet vertical erosion is just deepen the river. The river just cuts going deeper, but headward, a river is able to remove all those temporary